if I want to integrate this absolute value, could you do it on your calculator? It'd be very easy. Without a calculator, different story. With this absolute value, what you have to understand, normally a graph of a parabola looks like this. But with absolute value, what's going to happen is this graph's going to go down, and anytime it goes under to the axis, it gets flipped upside down and goes back up. So it's going to look something like this. And so basically, when you find the area from 0 to 4, you're going to have everything's going to be positive. Where here, it would have some negatives, but it got flipped over. Okay, so don't we have to find out where this graph crosses the x-axis and where it's going to flip? You have to be careful with that. So your interval, you have to find these points where it crosses. So when we do that, where does it cross the x-axis? It's pretty simple. Don't you set it equal to 0? Where does it cross the x-axis? You just set it equal to 0, and you solve it. Now, you could use quadratic formula, but this one's nice. What do you get when you factor? Negative 3, negative 1. X minus 3, x minus 1. So what's x equal? This one is 3. This one is 1. Hey, look at that. Isn't that 1 and 3? But isn't my area, aren't I going to do area like this? Isn't my area going to look something like, my area is going to look something like that? It's a parabola that gets flipped over. Okay? So, again, the reason we have to find this is for the interval 1 to 3, don't we have to find the opposite of the area? Because normally wouldn't the area be negative? Doesn't the area from 1 to 3 now be positive because of the absolute value situation? It's kind of weird. So here's how you set it up. The first interval is from 0 to 1. And you just simply do the normal equation. Now the second equation, wasn't it normally going to be negative? So don't I have to subtract that? And isn't the interval from 1 to 3? And is this last interval positive? Did it say the same? Yeah. So you're going to add the integral from 3 to 4. So basically all we did is we found the area of each piece individually, except this piece in the middle we flipped over. Now, if you didn't have the graph of this, how would you know that that piece, the middle piece, was going to be flipped over? Well, could you have taken 3 and 1, looked at the interval and plugged in numbers to figure which one have negative outputs, which ones have positive outputs? And from there figured out which ones need to be flipped. Also, if you just did all these areas one by one, you got it? If any areas come out negative, can't you just make them positive? Do you really have to put a minus here? Or could I just have whatever areas each one are, make them absolute value? I could also do that. So there's two ways. Either you change it to a negative, or you just take each area individually and make them all positive. However you want to think about it. There's multiple methods. Anywho, so let's integrate this. You integrate this, you get x to the third over 3 minus x squared. How do you get 2x squared? Well, isn't that x squared over 2, and 4 divided by 2 is 2? Now, for this one, I'm going from 0 to 1. All right, am I going to use the same function for all of them? So would this one be from 1 to 3? This one be from 3 to 4? Okay, x to the third divided by 3. Okay. Now, thank you. The last one should be 3x. Not plus c. It's a definite integral. Don't need plus c. Okay. So, let's plug in the answers. That's just the first one, but we're going to do all of them. So for the first piece, you're going to plug in 0 and then 1. So we would plug in 0. That's nice. Did you get 0? When I plug in 0 to all those, don't I get 0? Minus, let's plug in 1. What do you get when you plug in 1? That's 1/3. Minus, what's 2 times 1 squared? 2. And 3 times 1 is 3. So there's the first piece. Okay. Minus, well, didn't we just do 1 for this one? See the 1 here? Aren't we going to plug in 1 to this? But didn't we just find that answer right here? So won't it be the same thing? The 1/3 minus 2 plus 3. Minus, what number are we plugging in now? 3. Aren't we going to plug in 3 to this, though? Remember, this is my integral. We're plugging into the integral. I just didn't want to write it over and over and over again. So when I plug in 3, 3 cubed is 27. 27 divided by 3 is 9. Plugging in 3. Do you understand? You're going to go 1 to 3 now? Sorry. And the last one's going to be 3 to 4. So 1 to 3. Okay, 3 squared is 9, so that's negative 18. And 3 times 3 is 9. Okay, and the last piece, is that the same thing? Because aren't we going from 3 to 4? Isn't 3 the same? Anywho, so that's going to be the same as 9 minus 18 plus 9, which actually ends up being 0. Minus, and then we plug in 4. So let's plug in 4. 4 cubed is 64. So 64/3. 4 squared is 16. 16 times 2 is 32. And 4 times 3 is 12. Sorry, it's a lot of big numbers. Yes. I mean, just a lot of number crunching. What do we get here? Well, what's this? What do we get when we subtract those? Add those? Then isn't that 1? 1 plus 1/3 is 4/3. So we now have 4/3. This is 4/3. Won't this be 4/3? Isn't this 0? Isn't this 0? And this one, that's kind of ugly. But it's 64/3 minus 20. And 64/3 minus 20. I don't know what that is actually. 64/3 minus, this is 20. Well, 20 would be 60. So wouldn't that be 4/3? Another 4/3. That's kind of crazy. So isn't this going to be a minus 4/3? And isn't this going to be plus 4/3? Now, I messed up real quick somewhere. Where did I mess up? The last one's negative 4/3? Okay, something's... Oh, I did them all backwards. Shoot. Isn't it b minus a? I was thinking something's weird. The function is f of b minus f of a. Got it? It should be 4/3 minus 0. This should be 0 minus 4/3. Got it? These are switched. It's f of b minus f of a. F of b minus f of a. F of b minus f of a. It's the fundamental theorem of calculus. So this would be 4/3 minus 0. This would be 0 minus 4/3. Wouldn't that be a negative area? Which would make the negative into positive. This one's 4/3 minus 0. I did them all backwards. Don't do that same mistake. please. My answer is 4.